Based on the nature of forces acting between the constituent particles, they are categorized into, the crystalline solids are categorized into 4 types. That is, the first one is non-polar molecular solid, the next is ionic solid, the next is metallic solid, and the next is covalent or network solid. We will discuss them one by one. The first one which we are going to discuss is non-polar molecular solid. In case of non-polar molecular solid, it comprises of atoms or the molecule formed by a strong covalent bond. The first one, what we got? It comprises of atoms such as either of atom we know in case of helium, neon, argon, etc. or molecule such as hydrogen, fluorine, nitrogen. You know, this molecule are formed by the strong non-polar covalent bond, which are formed by non-polar covalent bond. So the next one, between this molecule or between this atom, they have weakest forces or dispersion forces. It means between the atoms or molecule, they have dispersion forces. No, these dispersion forces are weakest forces. Therefore, they have low melting point. They usually exist in liquid or in gaseous state. Next one, they have low melting point and usually occur as liquid or in gaseous state. So the next one, we know these are made up of atoms or molecules. Therefore, these are non-conductor of electricity. Next one, these are non-conductor of electricity. The next we will discuss polar. Molecular solids. This solid comprises of those molecules which are formed by covalent bond, but due to greater electronegativity of one of the participating atom, the bonds becomes polar in nature. Let us see here. For example, in case of hydrogen fluoride, this bond is formed by the sharing of electron. It means it is covalent in nature. But due to greater electronegativity of fluorine, these bonds are shift towards fluorine and it got delta negative and delta positive. This type of molecule is termed as polar covalent polar covalent molecule. And the solid which are constitute of this type of molecule is known as polar molecular solid. What we see here? Due to this, they create a dipole, and the force in this molecule, in this solid, is dipole forces. It means the first one, it contains the molecule formed by polar covalent bond. So the next one, in between two molecules in this solid, it is dipole forces. The forces in this molecule is dipole forces. You know, this dipole forces are stronger than London or dispersion forces, which is stronger than dispersion forces, which we have got in the previous one, that is non-polar molecular solid. It means the force in this polar molecular solid is stronger than the non-polar molecular solid. That's why they have high melting point in comparison to non-polar molecular solid. The third one, they have high melting point in comparison to non-polar molecular solid. They are also constitute of covalent bond. Therefore, they are also non-conductor of electricity. The fourth one, they are non-conductor of electricity. These are non-conductor of electricity because they does not contain free charges. So the next, they occur in liquid or in gaseous state. Usually, fifth one, at room temperature, they occur as liquid or in gaseous state. Whether they occur in solid or not? Yes, they occur in the form of solid sulfur dioxide or in the form of NH3. In solid state, they occur in SO2 and NH3. The next one, we will discuss hydrogen bonded molecular solid. In case of hydrogen bonded molecular solid, these solids are constitute of those molecules in which the hydrogen is joined with nitrogen, oxygen and fluorine by the means of polar covalent bond. The first one is that we get the hydrogen bond where hydrogen is attached with nitrogen, oxygen or fluorine. It means the first one, this solid constitute of those molecules in which the hydrogen is attached with only and only oxygen, the next one nitrogen, and the next one fluorine. Attached with oxygen, nitrogen and fluorine by the means of polar covalent bond. Clear? To the next, what we can say? These are also constitute of molecules, covalent bonds, having covalent bonds. Therefore, they are also non-conductor of electricity. The next, they are non-conductor of electricity. To the next, though they have also van der Waals forces, that is hydrogen bonded, they have weaker forces, therefore they usually occur in volatile liquid or in soft solids. They occur at usually these solid, they occur as soft solid or volatile liquids. Clear? Next to that, we will discuss ionic solids. We have an example such as sodium chloride NaCl, Na plus Cl minus. This solid constitute of ion which are joined together by the means of a strong electrostatic force. Clear? It means the ionic solid constitute of ion which are formed by the loss and gain of electron. It means what we got? The first one, these solids constitute of ions, and these ions are joined together or bind together by the means of a strong electrostatic force of attraction. These solids constitute of ions which are held together by the means of a strong electrostatic force of attraction. If these ions have a strong electrostatic force of attraction, then they should have high melting and boiling point. The next one, they have high melting and boiling point. Clear? We know these are ionic in nature, that's why they are brittle. The next is that they are special in nature. To the next, we know they constitute of iron, but in this case the iron are not free. They are held together by the means of strong electrostatic force. It means they are not free to conduct electricity. That's why they are acting as insulators. They are insulator, but we know they will conduct electricity. We know solid sodium chloride is non-conductor of electricity, but when we dissolve solid sodium chloride into water, then the ions are free, they will conduct electricity. Or they will conduct electricity when we melt them or in fused state. They are insulator, or we can say they are non-conductor of electricity, but conduct when in solution or in fused or molten state. Clear? They constitute of iron, but these iron are attached with each other by the means of strong electrostatic force. That's why they are not free to move. That's why they will not conduct electricity. But when they are dissolved in water or in solution state, that we call it as electrolyte, they will conduct electricity. Or in fused state or molten state, they will conduct electricity. Clear? So the next one we will discuss metallic solid. Now, in case of metallic solid, it is represented in such a way that the positive atoms are immersed in the sea of electron. It means the metallic solid, they are considered in such a way that the metal atoms are immersed in the sea of electrons. As we see here, these are the electrons. Here is the metal atom. In this case, a metal atom contributes one or more electrons. The next one is that a metal atom contributes one or more electrons. So the next one, we know these are negatively charged electron and the metal atom is positive, then they have strong metallic forces. They have strong, they have what we can say, they have metallic bond. In this case, we see we have electron, and that electrons are, these electrons are free electrons. And we know if free electrons are there, then they will conduct electricity when potential gradient is applied. It means, this next one is that they are good conductor of electricity together with heat. They are good conductor of electricity and heat because they contain mobile electrons. The next one, they are good conductor of heat and electricity because they contain mobile electron. You know, the metals are malleable and ductile. So the next, they are malleable and ductile. There. So the next we will discuss about covalent or network. Or you know, a wide variety of non-metallic crystalline solids are result of a large number of covalent bonds. It means what we got the first one. The first one is that a wide variety of crystalline solids wide variety of crystalline solid of non-metals are result of covalent bond. As we have discussed, these are network solid. It means these are zinc molecules. We'll take an example. These are why they are zinc? Because in this case the atoms are joined together by the means of covalent bond and they have long repeating unit, as in case of diamond and graphite you have studied in class 10th. These are zinc molecules. The next one, they are non-conductor of electricity. Fourth one, they are crystalline. It means their bonds, the covalent bonds are directional in nature.